Hello and welcome to the lesson video for 1-3 over distance and midpoint. And so we're going to get started right away. Hopefully you've had a chance to complete the 1-2 assignment and have graded it using the attached key. And then hopefully now you have also done vocabulary for lesson 1-3, so we can roll right into our video. So if you have your notes page out, we will get started right away. Alright, in the past we have graphed points on the coordinate plane. Well, now we're going to take a look at using those points and those values to find the distance between 2 points and the midpoint of a segment. So here's some new vocabulary for you. What we're going to talk about what distance means. You already kind of know what an irrational number is. We'll talk about that in class, but it won't really be covered in the video. And then midpoint, we'll talk about what that means, and then also what a segment bisector is. We'll talk about all those words in this video. Alright, so here we have our information about our distance formula. The distance between 2 points is the absolute value of the difference between their coordinates. So let's take a look at what your notes actually look like. You'll see this. The distance between 2 points is always a positive number. So right in here you want to write the word positive. Okay? So therefore it is what we call the absolute value. Alright, it's the absolute value of the difference, so subtraction, of the coordinates. The distance between 2 points is also called length. Alright, so here, those the blanks. Those highlighted words are the blanks you should have there in your notes. Okay? Alright, let's go ahead and take a look then again at our notes here. So this is our way of calculating distance just on a number line in just one dimension. We're only talking about one set of values instead of an ordered pair. But we're going to take the absolute value of the difference. So you're going to subtract in either order, it doesn't really matter. And the way we kind of talk about absolute value, that just means always positive in this case. And the way we do that is just to basically count on the number line or just to do the subtraction in such a way that you always get a positive value. And so here's our first few examples. Let's take a look. We want to use the number line to find QR. When they say QR without any symbol above it, they really do mean the length of segment QR or the distance from Q to R. Okay, those are what that means. When it says find QR, that's what it means. And so QR then is just equal to the distance between these, and we're counting by ones on the number line, so I can literally just count 1, 2, 3. So I know QR should be 3 units long, and we can do that by doing our subtraction. The absolute value of -6 minus -3. I know absolute value is a little bit of a challenge for us, so let me help you out. Negative times negative here makes this plus 3. -6 plus 3 is -3. And the absolute value of -3 is positive 3. But again, the short way to do that when you have the number line is just to count. So that's our answer. Okay? Once again, to find this using the number line, we can just count from -5 up to 3. 1, 2, 3, 4, 5, 6, 7, 8. If I were to do 3 minus -5, that becomes 3 plus 5. And since we're doing absolute value, I've set it up so that it's always positive. Either way, your answer is 8, like we got from counting. So we'd say AX equals 8. Okay? Went through kind of quickly, but again, it's just counting space on the number line. Make sure that your number line is given in increments of 1 before you start counting, though. Alright, now the main idea here is really using the distance formula to find length and distance in the coordinate plane. And so we have a formula for that is very important. Okay, our distance formula uses some square roots, and because we take the positive square root, it makes sure that distance is always positive. We're going to take the square root of these two quantities squared. The first quantity is the difference of the x-coordinates. We want to square that. And then add that to the difference of the y-coordinates squared. And really, I'll show you this in class, but this comes from the Pythagorean theorem. A squared plus b squared equals c squared. And we'll look at that in class as to how we get from here back up to here in the coordinate plane. But really, we're just plugging values into this formula and solving. All right? So we're going to find distance in the coordinate plane using this formula. So distance, we use a lowercase d to represent that instead of always giving specific values. The distance between 2 points means we take the square root of these values. x2 means the second x-coordinate, so we're going to take a look at our second x-coordinate, which would be 8, minus the first x-coordinate. So we're going to take a look at 8 minus negative 5. And don't forget that you get a double negative. Minus a negative really becomes plus positive. Squared. Alright. Plus the difference of the y value. So I'm going to take the second y value, negative 4, and subtract, that's a 6, and square that. Alright, so there's no minus negatives to change here. And then we can start simplifying. First thing you want to do is what's inside parentheses. 8 plus 5 is 13. And we'll square that. Plus negative 4 minus 6 is negative 10. We're going to square that. Alright. 13 squared is 169. And negative 10 squared is positive 100. At this point, you will always get a plus sign there. There'll never be a negative number. When you square a negative, you get a positive. So we get the square root of 269. Okay. Now, 269 is actually a number that does not have any perfect square factors other than 1. So if we wanted it in exact form, we would just leave it as 269. But let's go ahead and round that to get a better understanding of what the number is. And the square root of 269 is about 16.401. Okay, and we're not told where to round, so we can just give 3 decimal places is usually pretty good. So the distance between these points is about 16.401. All right, let's try that again with part B. We're going to use our distance formula. We're going to first take the difference of the x's. So that would be x2 and x1. We're going to do negative 3 minus 4. And then square that. Plus the difference of the y values. The second y value is negative 7. We're going to take negative 7 minus 3 and square that. Notice I keep my square root until the very end. So negative 3 minus 4 is negative 7. And negative 7 minus negative 3, or sorry, just minus 3 is negative 10. So negative 7 squared is positive 49. Negative 10 squared is 100. And so we get the square root of 149. Again, that is not a perfect square. Probably doesn't have any perfect square factors that work out very well. So written exactly, we could leave it like that, or we can use our calculators and get that that's about 12.2065, so we'll make it 207. Alright, and so that's the distance formula. We will be using the distance formula quite a bit this year, so you'll want to make sure that you eventually memorize that formula. I'll give it to you in most of the work we do here at the beginning, but you will use it so often that you will in fact memorize that. Okay, for our next example, or before we get to the next example, in class I'm going to show you how the Pythagorean theorem, which works for right triangles, and that's a squared plus b squared equals c squared, how we could use that to verify what we just did in example 2b. We know the distance from example 2b was 12.207, and so I'm going to show you in class how to make that graph on a coordinate plane and show you why we can get the Pythagorean theorem from that. Okay, so we'll come back to this one, so just kind of make a star by it and we'll come back to it in class. Alright, that leads us to talking about midpoint. Midpoint. You need to write this definition in for midpoint. The midpoint definition is the point halfway between the endpoints of a segment. All right, that's what midpoint is. It's the point that is halfway between the two endpoints. And so in our coordinate plane, we don't really talk too much about midpoint on a number line in one dimension because you just count halfway. But in the coordinate plane, we actually have to do a little bit more work. And so what we actually end up doing is taking the average of the x's and the average of the y's. Okay, we're halfway between the two x values, we're halfway between the two y values. That ends up being the average of each coordinate. So remember, to find the average, you add them up, divide by how many there are. And so that's how we find that. So this is another very important formula that you'll want to memorize. So we're going to practice using this here at the beginning, just with some straightforward problems. To find the midpoint, we simply plug in our values for x and y. This is x1, this is y1. This is x2, this is y2. First x and y coordinates, second x and y. So we're just going to plug those in for our midpoint formula. x1 is 5, x2 is -4. You could have written plus -4 or -4. And then the y values, we have 12 plus 8 over 2. And then we just reduce each fraction. Alright, so 5 plus -4 is 1. 12 plus 8 is 20, and then we need to reduce those if we can. We can leave 1/2 written as 1/2, but 20 over 2 is 10. So there's the midpoint between these two endpoints. Alright? I want you guys to try part B on your own. You'll need to pause the video to give yourself time to do that. But try part B by finding the midpoint by plugging in the values. Alright, if you need more time, again, push pause. Otherwise, this is what you should get. Midpoint is either -3/2 or -1.5, however you choose to write that, for x, and then the y value of the midpoint is -1/2. Alright, now it's a little bit trickier to find midpoint when you are actually, to find these problems using midpoint, when they give you one of the endpoint coordinates, but then they give you the midpoint, and you have to find the missing endpoint. Okay, where this time B is going to be the midpoint. So here is our midpoint for both parts of this problem. Alright, first, they tell you that a given coordinate of A, we want to find the other endpoint. So we're going to use some algebra to do this. Okay, so let me just set up a little diagram to help you see this. So for each one of these, this would be coordinate A, this would be coordinate C, and B is the midpoint. So for problem 4A, you are given this endpoint and this midpoint and asked to work backwards to find this endpoint. And so for the sake of time in our video, we're actually going to save this example to talk about in class. And so if you want to try it, if you think you know how to do it, go right ahead. Otherwise, we're going to just hold on to this until the next class period. Alright, and the last thing we want to talk about here is the idea of a segment bisector. A segment bisector is any segment, line, or plane that intersects a segment at its midpoint. And so if I said this is the midpoint, then the point itself is the segment bisector. But I could draw a line through that to get this and call that the segment bisector, because the word bisect means to divide in half. And so here's what I want you to write after the phrase a segment bisector. I want you to fill this in. A segment bisector divides a segment into two congruent segments. So a segment bisector will always take this segment and cut it in half, essentially, dividing it into two congruent segments. So here's what we know in example 5. We want to find the measure of QR if Q is the midpoint, which is also a segment bisector of PR. So what that tells me is that these are congruent portions. If these are congruent, if PQ then, segment PQ is congruent to segment QR, that means that the length of PQ equals the length of QR. Remember we talked about that in lesson 1-2. So what we can do then is plug in their values. Negative 6a minus 3 has to equal 4a plus 27. Alright, I want you to pause the video so that you can solve this equation for a and then plug it back in to find QR. If you need more time, go ahead and pause the video. Otherwise, this is what you should get. Alright, a works out to be negative 3. And when I plug that back in, QR has a length of 15 units. Alright, that wraps up our video. It's a little bit longer, sorry about that, but hopefully you got all the information you need and are ready to start this lesson assignment in class.